Hello, folks. Thanks for joining. It is 3 p.m. here in Los Angeles, so it's time we get this started. For some of you, it might be early morning hours. Just as a reminder, this is a second, almost identical session of the last workshop we did last Wednesday. So I'm going to cover the same stuff, but just another live session so I can answer any questions you might have. We can get into some more detail. So I'll start by sharing my screen here. Let's do a little introduction. Some of you might know me already. My name is Arman Gangar. I'm the CEO at Metaspike. We design digital forensic software with a cloud focus, especially emails. And as such, I do quite a bit of email work myself, email investigations, working on email servers, APIs, individual email messages, business email compromise investigations. So I spend quite a bit of my time looking at emails. So today I'm planning on covering email forensics generally. We might do some other sessions later on to get into more detail, maybe some server work or logs or APIs. For now, let's look at emails. I'll start with the visual appearance of an email. We'll look at electronic email data and metadata. We'll cover server metadata a little bit to see what we can glean from server metadata and how we can use that to complement our traditional email investigations. We'll talk about some forensic preservation strategies, and I'll leave some time to cover your questions and answers. Now, there's a quick Q&A area. I think if you want to get my attention, it's best to post a question there. I'm planning on stopping a couple of times to look through that and answer anything that has come up so far. And then we can go from there. So if you think of anything interesting, just flag it there and post a question. And when I stop, I'll go through them. So let's start by looking at a suspect message. And in this case, some of you might be already familiar with this dilemma. A lot of times when we start an email investigation, we don't get what we need. And that is, we don't get the original electronic message in its native format, but instead we get a printout or a PDF or something that's quite a bit degraded. So I'll start there with a PDF, which is pretty common for me. And I'll kind of walk you through how I look at it, what we can glean from that, and then what we could use as leverage to get more information, perhaps a forensic inspection or an electronic copy of that email message. So the PDF that we're going to look at is pretty simple. It is a 3-message thread between a couple of participants. So let's switch over to the PDF here. So I'll walk you through briefly what I look at here. So this is a PDF printout. It's one page, so pretty simple. So let's take a look, and I'll walk you through what I see here. And some of you might have your own way of looking at things. And if you have some interesting insights, feel free to either post them in the Q&A or get in touch with me later on. So let's assume for now that all we have is the PDF, all right? What can we deduce from this? Well, this to me looks like, first I'll look at the structure of the PDF. So it's clearly a printout. Let's zoom in a little bit to see if this is a vector PDF or a raster PDF. You'll see that as you zoom in, it remains crisp, so it doesn't get pixelated. So that tells me that this is a vector PDF, so consistent with something that will be printed directly from an electronic document like a Word document or an email client, rather than something that was likely printed on paper and then scanned back in. So it might have been printed from an email client. When I look at the format of it, I'm familiar with this format. Some of you might know too. This is what MacMail printouts look like. So this tells me that I'm putting in the back of my mind, MacMail might be involved here as an email client. MacMail printouts look like this generally, and that is the metadata fields appear on the left side, right justified like this in this order. Next to them, there's the values of the metadata fields. The from name is bolded. There's an avatar on the right side. In the absence of this person's contact record having a photograph, and that would be the person's initials as a replacement, a placeholder. and then there's a dividing line here, and then the message body follows. So it makes sense to me. It looks to me that it's consistent with MacMail. Perhaps it was exported directly from MacMail as a PDF. And actually, if you look at the properties of this PDF, I don't want to get into a PDF exam here, but very briefly, if you look, you'll see Mail as the application. You'll see macOS 10.15.5 consistent with Catalina Quartz PDF context. So that's how Catalina converts to PDF. So that all makes sense to me. So let's skip over the PDF part for now because that's another workshop. So let's look at the contents of the PDF to see if there's anything interesting here. I'm going to start from the bottom up and look at what I see here as far as content goes. So I'm basically seeing three messages here. There's a message in the bottom that appears to be from Kenny Galloway to Ernie. So from Kenny to Ernie, it looks like Ernie replied back to Kenny, and then finally Kenny replied back to Ernie and copied an additional recipient. And the flow of the message bodies kind of mirror this. So there's this message that says any news on the new hire, and it's signed Kenny. And then the response is, yes, let's mark tomorrow as the date of hire for Benny. Thanks, Ernie. And then, great, I'm copying Alessandra as well, Kenny. So pretty simple email thread. So let's look at what we see on the face of this email and if we can find any clues here. This part is simple message body on the bottom. There's nothing exciting there. Any news on the new hire, Kenny, that's fine. The next line or the next two lines, let's say, is a quote string. So this would have been created when Ernie replied to Kenny's message. So this is not part of Kenny's message. This is actually something that's a function of what Ernie did. And the quote string starts with on, the day of the week, a date, and a few other things. So let's pause here for a second and take a look at quote strings and talk about what we can glean from quote strings. So I'll switch over to a little bit of a write-up here on quote strings. Essentially, quote strings are something that email clients create when they interact with messages, especially when they reply to an older message or forward an older message. Usually an email client, depending on its configuration, takes the older message or the whole chain and will include that as a coded body at the bottom of the new message. And each email client has its own flavor of handling this, and that could by itself be a clue that tells you what email clients might be at play here. For example, if the web interface of Gmail or G Suite is used, then your quote string might look something like this. It starts with on and abbreviation of the day of the week. There's a timestamp here. Finally, the sender's name and email address. Whereas if this was MacMail, the Apple Mail client on the desktop or iPhone, you would see something similar, but it wouldn't have the day of the week, and it would have a comma here after the year, another comma after the AM, and it would finish like that. Yahoo Mail's web interface is a little bit different. It has the full day of the week, again, a date, there's a time zone, and the same stuff afterwards. Whereas if you have Outlook replying to or forwarding a plain text message, then you would have this original message line at the top, surrounded by 5 hyphens on each side, and then a summary of the messages, the original messages metadata. So this not only depends on the email client version, but also what type of message it's interacting with, and also date and time sometimes, because older messages from Gmail and G Suite's web interface had a slightly different formatting. So you have to take into consideration the timing too, and that might give you some timing clues as well. For example, if you have a Gmail string where there's a comma after the AM, then that might tell you, oh, this must be a Gmail message that was probably a few years, it was sent a few years back when Gmail used to do that. So you can glean two things from this, at least. Number one, what email client might be at play, and number two, perhaps some timing information at a minimum. So let's switch over back to our email message. And let's look at our code strings here. So the first one here looks to me that it's very similar to what I just showed you for Yahoo. So this is consistent with Yahoo's web interface, and it has a full day name and a bunch of other stuff. So this I put in the back of my mind, hey, this person, Ernie, has a custom domain, example.com, but that doesn't necessarily mean that he's not using Yahoo, because Yahoo also offers custom domains as part of their business plan. So perhaps he's on Yahoo Business. Let's keep that in mind, because his code strings are consistent with, or this one is consistent with Yahoo Webmail. So I'll keep that in mind. The second thing I noticed is this code string is different than this. So that might be multiple email clients involved here. And when we look at this code string, this is consistent with Gmail's web interface that I just showed you. So again, I'm putting that in the back of my mind. This is generated when Kenny replied to this message. So Kenny might be using Gmail on the web, which kind of makes sense because Kenny is using a Gmail address anyway. So that kind of matches our expectation there. So he's likely using Gmail, and he might be using Gmail web rather than an email client. So let's pause here for a moment and think about what we're looking at and are there any problems here. So when we scan through the code strings, I would look at a few things. Let's go through this one. It starts on Tuesday, a certain date. So first thing I would check would be, is January 7, 2020 really a Tuesday? Because a lot of people make this mistake when they forge emails. They would change the date but forget what day of the week that is, and that might be a mismatch. In this case, I checked and it is really Tuesday, so not a problem there. Same thing here, Tuesday, January 7th. The sequence of events between these two code strings lines up. So this is 11:25 a.m. and 6 minutes later at 11:31, there's a response there. That makes sense. One thing that jumps at me here is this. Here, Yahoo Webmail code strings have a time offset associated with them, and this is PDT, which is Pacific Daylight Time. But in January, in Pacific Time, you wouldn't observe Daylight Time. It would be winter, and you would expect to see Pacific Standard Time. So I would have expected this to be PST rather than PDT as far as Yahoo Webmail is concerned, at least. So that's a discrepancy to me. It's not enough to just invalidate the whole email string, but I'll write that down as a little red flag to keep in mind. Let's move on to this one. This one looks, like I said, Gmail style. We have the day of the week, the date and time. We don't have a time offset here, which is what Gmail does, so no problems there. So nothing to write home about. Moving on to this area here, so the CC recipient makes sense. He says he's copying Alessandra, so there's an extra carbon copy recipient. 2, this is not going to be bolded as per how Apple Mail handles the formatting, so that makes sense. January 7, 2020 at 10:32 a.m. So this is kind of a problem because here we had a chain of events coming from January 7, 11:25 a.m. and then a response at 11:31 a.m. Finally, Kenny responds again, and this shouldn't be before 11:31 a.m., but it shows up as 10:32. This could be because of this issue we encountered with the daylight savings. So let's keep this in mind too. It might be connected. Perhaps because there's an issue with daylight savings, maybe this would have been 11:32 a.m., but it's showing up as 10:32. It could be an email client issue or a general date issue with email. We don't know for sure yet, but problematic. Nevertheless, we have the subject. Now, after I did the last session last Wednesday, one of the participants made an interesting comment. Even in this, there's something to look at. The capitalization of these subject prefixes can also give you a clue. Sometimes they will be all caps, like R and E would be all capitalized, and that's more consistent with desktop email clients like Outlook. And sometimes they will be like this in camel case, which might be along the lines of what a webmail client would do. Of course, you can't tell, or you can't just categorize just based on that. But if the story has to match the specific email client, then you would check the behavior of that email client and see if it matches what you're seeing. So it's still a data point, although not a hugely important one. So this is what we're seeing from the face of the email. It's not much, but it gave us a few clues about how this was likely created, from what program it might have been exported. That tells me that likely an electronic copy of this email existed or maybe still exists, so that could be good leverage. It gave us some pointers about some date discrepancy here and the time zone discrepancy here to keep in mind, and it gave us some information about what email clients and services might be at play, as in Yahoo and Gmail's web interface, Yahoo's web interface. So all good and well. Now let's switch our focus over to the message itself. So now let's assume that we actually gained access, we made our case, we pointed out those discrepancies in the email message printout, and we leveraged that to get access to the native format of the email message. So now we're going to talk about what the original email message looks like and what we can learn from there. So we'll talk about the message data, metadata, like message ID, references, trace fields, content length, DKIM signatures, and all kinds of header and body type metadata. So let's switch over again to the message itself. So this here that I'm showing you is a EML file. And that is great in this case because we're dealing with potentially a Gmail or Yahoo type email message. And in that case, if the email was requested over the internet as an email client, then the server would transmit that email in internet message format, which is IRC 5322, and you would get a MIME message that looks like this. You don't want a PST or an MSG in that case because that requires a conversion, and a conversion is bad because it prevents you from doing certain types of analysis, which we'll see in a little bit. We want to be as close to the original format of the message as possible, and in this case, that's going to be a MIME message. And even in the case of some other email systems like an Exchange server, if you're requesting the email over the internet as an email client, then MIME format usually still your best bet. If you're working with local emails, like a local cache of emails in Outlook, or a message that was exported as an MSG, or maybe an Exchange database on the Exchange server, then you might be better served dealing with that native file format as it's maintained in the during the regular course of business. So it might be a PST file or an OST file or the Exchange database. MSG would be kind of rare because an MSG file is not how emails are typically created and stored, but it could happen if somebody takes an email message from within Outlook, drags it out for archival, and the original is lost, that's the only copy, then they might be your native file. Anyway, so going back to this, let's look at the EML file that we have. And again, I'm going to start from the bottom and work my way up. So let's take a look at what we see here first. So I'm going to start with the body first. So I see some stuff that I would call the payload of the message. So this is the message's body. Let's start by pointing out the MIME boundary delimiter. So we have these items here. There's one here, and one at the bottom, and there's a declaration up here. So let's talk a little bit about this first. So this is a MIME message as defined by the specification, like I said, RFC 5322, and a MIME message has parts. So it's a multi-part message. And the MIME boundary delimiter here that I'm highlighting is the delimiter that separates those parts. So it tells the email client or the reader where each part begins and ends. And sometimes there will be a description of the part too. So it separates the different parts. So if you focus on this line here at the header, it says essentially the content type is multi-part alternative, and the boundary is this. So multi-part alternative tells me that this message has multiple MIME parts, and the different MIME parts are alternative to each other. So it's essentially the same content being presented in multiple different ways. So if you look at the parts here, as delimited by this delimiter, we have this one part that's coded, printable, encoded, plain text that represents text, and it's UTF-8. And then on the bottom, we have again UTF-8 text. It's coded, printable, encoded, but in this case, the text represents HTML, not just plain text. So we have two versions of the message body. To summarize, we have the plain text version and we have the HTML version. Now, I want to start by comparing these, because since this is multi-part alternative, then those body parts should be alternative to each other, so they should roughly say the same thing. So how can we compare? Well, one of the easiest ways is to have this rendered for you by an email client. You could render it yourself too. I'm going to use an email client like Outlook. Pull it up here. A bunch of email clients here. And it looks something like this, and Outlook renders it nicely for us with it decodes decoded printable encoding and renders the HTML, so it looks like this. So I'm going to scroll up over, and what I'm looking at here is, since this is the same message body, supposedly it should match, right? It should say the same thing approximately. So it starts with, great, I'm copying Alessandra as well. It says, great, I'm copying Alessandra as well. Kenny, this coding string matches when visually inspected. Next line says, yes, let's mark tomorrow as the date of hire for Benny. Here it says, yes, the apostrophe is encoded here. That's fine. Let's mark today as the date of hire for Benny. Well, here's our first discrepancy here. Here it says today. On the decoded HTML body, it says tomorrow. So that's a discrepancy. This could have been caused by somebody that's editing the message after the fact and neglecting to edit both sets of bodies to make them match. So they might have edited just the HTML version of the body, as you would see down here, where it says mark tomorrow, and maybe they didn't edit the text version and they caused the discrepancy. If they had made that edit in an email client like Outlook, you know, Outlook allows you to edit messages and save them, then typically the email client will be smart enough to sync that up. So the email client would make the edit in whatever body you're seeing now, and then when you save it, it would apply the same edit to the text version, so it would recreate the message with matching MIME parts. So if there's a discrepancy like that, then most likely that person edited this outside of a proper email client, perhaps themselves manually. So that's something to keep in mind. Let's talk a little bit more about these MIME boundary delimiters again. So I'm going to point you here, and I'll show you some information about them. So these MIME boundary delimiters are important, as you know, just by themselves, because they also give you some information about what email client might be at play here. For example, Gmail API and webmail has their own style of creating MIME boundary delimiters, whereas Yahoo webmail delimiters look like this. Outlook, when used via IMAP, looks something along these lines, and Apple Mail looks something like this. And in some cases, not only do you get what email client might be at use, but you might find some hidden timestamps in there. So let's look at our item here to see what we find out. So in this case, we are looking at these MIME boundary delimiters again. Before I get into the data, another thing I would want to check is that they match. So there should be one value and we repeat it exactly the same way across the board. The appearances of it in the body should be prefixed by two hyphens, and the last one should have the two hyphen prefix and a two hyphen suffix. So this should match the spec, essentially. If somebody manually edited these, there could be some problems there that you could catch. So they match, so we're good there. The next thing I want to do is throw this into our Gmail MIME boundary delimiter. I think I'm sharing only my presentation here, so I'll share my entire screen so you can see that. So I'll throw this into our Gmail MIME boundary delimiter decoder, which you can find on our website, and see if we get some useful timestamp there. And if you decode this, actually, if I highlight here, this part up until the last 2 bytes is the part that contains the timestamp. And when you decode this, again, there's step-by-step guides to how do you decode this on our website. You get a timestamp that looks like this. So immediately I wonder, hey, does this match the apparent date of our email message? Because it should. This would have been created when the email message was packed up and prepared for submission by the email client. And it doesn't. The email message we have shows January 7, 2020, 10:32 a.m. And this was in PDT time zone, if you recall. So shift that by 7 hours to UTC will be, let's see, 5:32 p.m. Here we have something that's entirely different. Well, in the UTC -8, it will be 6:32 a.m. Here we have June 23rd, 2020, 6:32 p.m. And some minutes. So not only does it not match, but it's also concerning to me because the minutes match and even the hour matches when you time shift this, but the date doesn't match. So the reason that's concerning to me is that it's a pretty classic recipe for somebody to just shift the date without going into much trouble. They would just change the day and the month, or perhaps the year if they need to, but not touch anything in the hours and the minutes or the seconds. So recreate a new shifted time to fit their narrative. So it looks like something like this might have happened here based on what we're finding in the Gmail MIME boundary. Now, why do we see timestamps here in the MIME boundaries? That's because the email client, in separating the different MIME parts in the message body, has an incentive to create unique boundaries. You don't want them to collide with some other legitimate text in the message. And when doing so, the email client utilizes some data points like process ID, sequence numbers, and timestamps. And the current date and time with high precision would be pretty unique. So you don't want to get the timestamp with minute or hour precision, because then somebody could send multiple messages within that minute or hour. But if you get into more precise timestamps like seconds or milliseconds or microseconds, then your chances are pretty high that you will be creating some unique MIME boundary delimiters. So in this case, you see that we have 6 digits after the second. So we have microsecond precision on these Gmail boundary timestamps. So we got some interesting and good information here about the timing of the email. Let's see what else we find. So another thing I would like to look here, and it may not be super clear at first sight, is the body of the message. I'm gonna pull this up in a different tool to make it a little bit clearer. So we said when we looked earlier that the plain text body and the HTML body were encoded with coded printable encoding. Now, one thing about coded printable encoding is that it limits the line length to 76 characters. So that is when it encodes and wraps the lines, it wraps them in a way that a line should not be longer than 76 characters. And the result of that is kind of a blocky looking chunk of text that lines up on both ends. But when I look at this, I see that block is interrupted in a few places. So I have a blocky looking text here, but on a few lines, I see that the line actually sticks out and doesn't wrap in the right place. So that also gives me some clue that those lines might have been manipulated. So that could give you some good data points about, you might find out that the email has been manipulated, but you may not know exactly where. This could tell you where that is likely to happen. Perhaps if these dates were manipulated, for example, then in changing the date, they might have caused this line to go over, and maybe they didn't know that 76 characters was a limit, so it would have to be wrapped accordingly, and we have some discrepancies there. So that's another thing to look at, the line length and the consistency of it. You would expect to see a straight line going down here when you look at coded printable encoded UTF-8 text. So that's something else that we want to look at. Another thing that, while we're talking about the content type and the boundary delimiters, this part can also give you some clues. So this tells me multi-part alternative. Like I said, if you were looking at a message that had an attachment, then I would expect to see something along the lines of multi-part mixed. So that's something to pay attention to too. If your message doesn't have an attachment, but it presents as a message with attachments, then it could have been derived from another message. So that could be some foul play there. All right, so let's keep going here. So we covered essentially the body and the text body, the HTML body and the text body. Before I move on, one more thing. You might see in the HTML body some indicators of email client as well. For example, you might see some HTML classes, some CSS classes that give you clues on what client might have created that HTML body. Especially Outlook is notorious for this, and it would leave a huge amount of artifacts that clearly identify itself in the HTML body. So that's something good to check to determine email client if necessary. All right, enough with the body and the MIME boundary delimiters. Like I said, check these delimiters for dates and email client info. Let's move on. Let's go to the header fields here that we see when we look at the rendering of the email. So we have a CC field, no problem there. We know that this person was carbon copied based on what the email looked like. We have the to field, Ernie. We have the subject. We have a message ID. Let's stop for a second at message ID because that's kind of an important field. So what can we learn from the message ID? A couple of things. Number one, the first thing we should address is that these message IDs are designed to be unique. So one of the first things I check is if I'm dealing with a collection of messages. So let's say that I received a mailbox export or I received an electronic document production and I'm focusing on one message that's suspect. Then I would run the message ID of that suspect message across the collection, or I would run a duplicate check across the whole collection and see if there are any duplicate message IDs that don't belong to the same message. If you do find something like that, then that's something to scrutinize because there should not be duplicates there. Each message should have its own unique message ID. So if two seemingly unrelated messages have the same message ID exactly, then that's something to pay close attention to. In this case, I have just one message, so I'm gonna not worry about the uniqueness of it, but I will worry about the suffix of it. And that is, this ends with mail.gmail.com. So this tells me two things. Number one, it's consistent with what I was expecting because this message was sent from Kenny, sent by Kenny from Gmail, and it has a gmail.com suffix in the message ID, which makes sense. The other thing is it says mail.gmail.com, not just gmail.com. And that's consistent with a message that was sent from Gmail's web interface or Gmail API, so something like the Android Gmail app or something like that, but not IMAP. And that's also consistent with what I was thinking because we had said based on the code string earlier that Kenny was likely using Gmail on the web, and this lines up with it. If you see just gmail.com without the mail, and that's more consistent with an IMAP client like Outlook sending messages through Gmail, connected to Gmail. Something to keep in mind. Let's move on to the date. We see Tuesday, January 7, 2020 here, 11:32 a.m. We see the -7 here as the time offset. So seeing the time offset itself in isolation doesn't give us a whole lot because we don't know exactly what time zone this person is supposed to be in, and it doesn't tell us just by looking if it's in daylight savings or not. But we've seen in other parts of this message the PDT time zone, which is consistent with -7, UTC -7. So this is likely UTC -7, and it is a problem, like I said, based on January in Pacific time. So it's still the same red flag reiterated. We have the from field from Kenny Galloway, no problems there. Here's another interesting field. So in reply to, so this in reply to and references are fields in the spec that are used to tie things together. So when we're looking at this message, this tells us that this message is in response to an older message. And in this case, the older message has an ID that ends with mail.yahoo.com, which makes sense because if you recall, I had said that based on how this code string looks, our guy Ernie here might have been using Yahoo on the web, and that would create a mail.yahoo.com type message ID. And when that message is replied to, the in reply to field might show that. So we're good there, and that makes sense. So the theory checks out still. Here's another hidden timestamp right here, this time in epoch time. I had created a quick tool to decode this before the last presentation, so let me use that real quick. So when we put this in, we see June 23rd, 2020, 6:31:05, 9:76:000 p.m. So this kind of matches with what we had seen from the MIME boundary delimiters here. Let me pull that up too. All right, so let's look at these side by side. So the Gmail boundary was 632.31. This Yahoo message ID tells us 631.05. Well, that makes sense because the Yahoo message ID's hidden timestamp should be related to when Ernie sent his message, which is 631. Whereas the Gmail MIME boundary is related to when the final message got created, because in the final messages we see now, the older MIME boundaries are no longer there. This is a new message of its own, although it references some of the older messages and those messages bodies have been included here. This is a new message and it has its own MIME boundaries. So we have this new timestamp. It matches with our theory that this message might have been time shifted. We still get the same timing information that jives with the Gmail boundary information. So let's keep going. Well, in the references, we also see the message ID from gmail.com, so no problem there. We have a MIME version header that says 1.0, which makes sense. That's the spec right now, so that's what's expected. Now we're getting into the trace headers little by little. So we have a received header with SMTP ID. And if you look carefully, here is another hidden epoch timestamp. And it's followed up by another human readable timestamp. So the human readable timestamp says January 7, 2020. Let's see what the epoch timestamp says. Well, this doesn't say January 7. Again, this says June 23rd. So it looks like there's a theme here. All the hidden timestamps are in June 23rd, and all the human readable timestamps are January 7th. So it could be that the suspect thought they changed all these dates by shifting them, but they didn't get some of the dates that are not immediately clear to the layperson. All right, so let's go and move on to the next two fields. So these are the DKIM signatures. Let's take a brief look at what that means for us before we dive in. So DKIM is a specification and it's a mechanism for transmitting entity to claim responsibility for a message. So how do they do that? They essentially take the payload of the message and a selection of its header fields, and they hash the payload, they combine it with the headers, they normalize that, and then they sign it with their private key. And then they post their public key as a domain name system record, a DNS record, publicly available. So what that does is when you receive the message on the receiving end, you can query that DNS record, get the transmitting entity's public key, and calculate your own hashes and verify the signature. If the signature verifies, then that's pretty powerful, because that tells us that at least at the moment that that entity had and verified that message, it was authentic, because the suspect is not going to have access to that entity's private key, so they could not forge that that signature with the technology that we have available now, or at least not easily. So that's pretty powerful. So let's go back to, and in summary, this gives us basically the hash of the message body and the headers on a silver platter. It's very powerful to authenticate. Let's look at, again, how our message was looking and how we can use this. So I'm going to look at one of these. They're about the same thing. Let's follow along and look at what this gives us. So we have this DKIM signature header field. It starts with this tag that says v equals 1. So that's the version of the DKIM specification in use here. Version 1 is all we have, so that's good. The algorithm is the A tag. In this case, it says SHA-256 was used to do the cryptographic work on this. The C tag is the canonicalization algorithm that's used. So that's essentially the normalization that's done on the header and the message body. There are two different flavors of this. If it's relaxed, then it allows for some flexibility in especially white space at the bottom of the message and among the header fields and stuff. Whereas if it's strict, then there's not much leeway there. Most of the time you'll see relaxed here, and the spec of it is out in the open, so you could use that to do your own canonicalization, essentially. D tag is the domain that's claiming responsibility or claiming essential ownership of this DKIM signature, so they signed it. And the S tag is a selector that you would use to create the DNS system to get that public key for that entity. And then after this, the H tag lists a list of header fields that were included in the calculation of the DKIM signature. The BH tag lists us the body hash, and the B tag is the signature itself. So if you look at these two, they're pretty similar. The BH is identical, so that tells us that the SHA-256 hash of the body when these two different DKIM signatures were calculated was the same, so they must have been around the same time. The signature itself is different, and that's expected because the selection of header fields included are different. So they included different fields and they arrived at different signatures. And not only that, but also the domain that's signing and the selector, or the selector is the same, but the signing domain is different. So very likely the key pair that was used is also different, so it has a different signature. Now let's do a quick look at what this means for us. How do you retrieve this data? I'm not going to get into a full DKIM manual verification here, but to show you how we can find that. So let's go query this. Let me take this selector here. So you could, for example, go to, right into my second monitor here. Let me bring this in view. You could go to MX Toolbox, for example, and they have a super tool here that you can use. It does a bunch of different types of lookups, but what I'm going to do now is I'm going to query gmail.com, and I'll put this as the selector. And if I do a DKIM lookup on this, it tells me that my key type is RSA and my payload, which is the public key, is this. So then I grab this public key from here and I do my DKIM verification and I verify if everything is making sense or not. So let's talk about a few things here. Well, first of all, without going too far, I will tell you that the DKIM signatures for this message don't verify. And you can check that manually, or you can check that with some tools like DKIMPy in Python is a good one, for example. But I suggest that if you're interested in this, you definitely do at least one DKIM signature verification completely manually. That'll show you exactly how it works and what you can get from a DKIM signature. And then once you're comfortable, you can do the rest automated, and that's easy. Now, as far as the DKIM signature goes, one of the most important parts of this, I would say, arguably, is the D tag, the domain, because the D tag tells us the signing entity. So you could have a DKIM signature here, and the signature might very well verify, but the entity that signed it, if it's not credible, then the signature is pointless. So for example, here it tells me that gmail.com signed this. So I'm getting the public key by querying Gmail's public records and finding their public key. So that's meaningful. But if this said something completely unrelated, like bluewineapartments.com or something like that, that's unrelated to the entities that are involved in this, then that has no weight. That doesn't mean anything to me. On the contrary, it might signal to me that there's something fishy about this message. So in this case, the signing entity is gmail.com, makes sense. This domain might be unfamiliar with for some of you. It's 1e100.net. This is one of Google's domains. It's not a public-facing domain, but it's something that they use in the back end. And 1e100 is a scientific notation for Google. So they use that for some things. So it's not a malicious domain there. So it's part of Google's DKIM signature. So it makes sense. So I don't have a problem there. But in summary, we have these DKIM signatures here, very powerful. We attempted to verify them for this message. They failed. This is good to have. And this is one of the reasons why I always prefer examining messages from somebody's inbox rather than somebody's sent items folder, because when you look at the incoming message, since it's traveled already, depending on the email providers that are at play, you get the DKIM signatures. If you look at the sent items folder, the message hasn't traveled yet, so you're not going to find DKIM signatures there, and that's not going to be super helpful. So this is good to have and very good to know how to deal with this. Now let's move on again to authentication results. So we had the DKIM signatures. The next field here is essentially a declaration by an entity that's telling us when they authenticated the message, what they found. Now, is this valuable? Well, it's better than nothing. It might tell you some information about what they looked at the time, but it's not something that's hard to forge because it's just a plain text item here. So this could have very well said DKIM fail, and somebody could have edited this to make it pass. So I can't rely on this because I can't authenticate this. It doesn't have a public key signature or anything like that. Unless this was included in a DKIM signature and it was verified as part of the DKIM signature, which doesn't make sense because this comes after the DKIM signature. So in this case, I'm not going to give this much weight, but let's talk about this because I like to just go line by line and examine everything I'm seeing here. So here, the authentication results were from Google. So this is Google's style of declaring their results that they found. The first line says DKIM passed, and the signing entity was gmail.com, and the header, the selector was this, and the signature that they're referring to here in this authentication result field is this one. The first 8 bytes is this one. So if we look through them, we see that they're talking about this signature because the first 8 bytes matches what's listed here. So this authentication results is for the DKIM signature that's right below. Makes sense. And then the next one is about standard policy framework. So this standard policy framework is essentially a mechanism for the owner of a domain to give permission to an outside entity to send emails on their behalf. So for example, it might, to give you an example, let's say that I have a domain and I want to use an outside service provider to do email marketing for me. So they're going to be sending domains on my behalf, and I'm going to instruct them to do so. So I could go into my DNS records and I can change my SPF records to explicitly state that this IP address is allowed to send emails on my behalf. So if somebody else is doing sending emails, then they're not authorized, essentially. So that's what it says here. And you can query this again from SPF records. So if you looked at google.com here, let's use the same tool here and check the SPF records. You see that there's a redirect here. We follow the redirect and there's multiple blocks of IPs that are allowed. So I'll start looking through them. If you look at this IP there, so the permitted IP here is 209.85.220.41, and here we have 209.85.128.0, but it's 17. So if you look at the IP range for this, it's going to be 209.85.128.1 to 255.254. So that covers our specific IP address here. But this in and of itself doesn't really mean much because this is sent by Gmail. And this is essentially saying Gmail is listing one of their own IP addresses as an allowed IP to send emails. Yeah, that's expected. The last one is the DMARC line. So here it says that DMARC passed, and here we see some information about the policy. So here it says that this is about what happens when DMARC fails. So the policy is none. So if DMARC fails, then it will set in a way that no action should be taken. If this indicates subdomain policy, so if an email was sent from a subdomain of gmail.com, and if DMARC failed, then that email should be quarantined. So that's not really something that Gmail is allowing. And this position here says none. So that means no action was taken. In this case, DMARC passed anyway. So we don't even have to worry about what happens if it failed. Again, this is something you can query. So you can look at the DMARC records. Again, let's take a look at gmail.com's DMARC lookup. And that tells you about the policy being none, the subdomain policy being quarantined, and here's the additional receivers part where this is where the notifications should go. So if an entity processed this and DMARC failed, for example, where should that fail notification go? And that's this email address. So essentially, by doing your own lookup now, you can validate if the information listed here is still accurate or was accurate, perhaps. Similar stuff here. We have the SPF record. Same thing, same IP address, permitted sender, client IP this, so nothing new here. Let's move on. let's look at this next trace field. As you know, these trace fields are built up from the bottom to the top, so we're following in that order. So we see some information about a Google server receiving it from another Google server. We see some Google IP addresses here. But here, there's something a little bit tricky. This text editor is not highlighting this correctly. But if you look closely, there's another timestamp here that's in human readable format. I think it just got mixed up with the rest of the text here, and it didn't catch the suspect's attention here. So we have a human legible time that says June 23rd, 2020, 11:32:31, and that matches with this June 23rd, 2020, with some time offset, of course. So that's something else that's helping prove our point that this is more likely the real date of this message. And then 4, this email address, Google Transport Security, there's a human legible address here, and that matches the apparent date of the email, but most likely it's not the correct date. So let's keep going. We have the return path. So this is part of the specification again, and this is also called the envelope address. This is something that happens when the message is transmitted via SMTP, and you want to mark where non-delivery reports and bounces should go. And this might come in handy in cases where you may not want your bounces to go back to your primary mailbox. So again, going back to the older example, let's say that I have a domain, I send emails from my own Outlook, but I also engage a third-party service provider to do like bulk email sends, to do email marketing. And when they send emails on my behalf, they put their own return path, a custom generated path that represents my account with them. And they process those returns and they figure out how many emails bounced and which participants should be taken off the list perhaps. And I don't want to see those in my own mailbox. So they don't get delivered directly to me. They get delivered someplace else. So that's what the return path is. For a regular email send, if you're sending an email from your Gmail, then most likely the return path is going to be the same thing as your email address. So when the email gets returned, it bounces right back to you, and you see that it bounced, and you take some action. So it's not surprising, makes sense to us. Another received header here. We have some IP6 addresses and SMTP ID, where I'm seeing another epoch date here in hiding. Let's decode this too, as I'm sure, yeah, this is again going to be the same June 23rd. If you pay attention, all these dates are in millisecond precision, so they're not going all the way up to microsecond, but they're still pretty precise exactly for the same reasons to make them unique and stuff. Another received header, another SMTP address. We have a legible time stamp that matches with the apparent date of the email. And finally, we have a delivered to header that shows you where this message was delivered. So this tells me that based on this and the other references here. So I'm looking at the copy of this message as it got delivered to Alessandra, not the other recipient, because she was copied here. So we're looking at the message from her inbox, essentially, which makes sense. So all in all, we've gone through quite a bit of trouble to scan through the message line by line and looked at the message body, discrepancies in the body's contents, in the body's encoding. We found some clues about timing information from the MIME boundary delimiters and message IDs and some hidden timestamps in the trace fields and a bunch of other places. DKIM failed as expected. So this email is looking pretty bad and almost certain that it's a fraudulent email. And we just build our case little by little, starting from what it looked like from the PDF printout to what we saw in the MIME version of the email. And now what's next is, of course, server metadata. So we looked at the email itself, so printout, underlying email. Now we need to look at the server metadata. And let me start by telling you a little bit about what I mean by server metadata. So the things we looked at so far were the things that we've seen within the message. They were contained in the message and they traveled with the message. Server metadata are things that are outside of the message that are stored on the server about the message. So kind of along the lines of file system timestamps, for example, how you might have creation and last modification and last access timestamps. They don't travel with the file unless you take some precautions to carry them over. They are kept on the computer, but they're about the file. As opposed to internal document timestamps that you would find in an Office document or a PDF that are actually within the file and they travel with the file. So we have server metadata that contains information about the email on the server. And this server metadata applies to a bunch of different server types. For example, for IMAP servers, the most commonly used metadata fields that I refer to are the UIDs, so the internal IDs of individual messages, the IMAP flags, and internal date message attributes. So I'll talk about these briefly. I don't want to get into too much detail here because it might take time. But the UIDs are essentially sequential identifiers that are assigned to messages in the mailbox. They're important because they are sequential. Like I said, they increase as new messages arrive. And if messages are deleted from there, then that leaves gaps. So that tells us a couple of things. Number one, if you're trying to prove or disprove if a message has ever arrived in a certain mail folder, then you can look at the time period in that mail folder and figure out if there are any gaps there where that message would have been. If there are no gaps, then that could be a point towards proving your case that perhaps that message never arrived there. The other thing is if an UID is out of sequence compared to its neighbors, then that message might have been manipulated or uploaded after the fact or migrated, so there might be something off about that message. The internal date is kind of similar to a file system creation timestamp, and it represents when that message was created in that mail folder. Now, you might think that this should be identical to the origination timestamp that you would find in the message's header, or one of the trace fields, like the last trace field that represents the delivery time. And normally you'll be right, but there could be a divergence there if the message was manipulated after the fact and synced back to the server, or if the message was copied, or if the message was migrated, like, you know, a whole migration took place way after the fact and a bunch of messages were pushed back into a server, then the internal dates associated with those messages might reflect the time of that copy operation. So in that case, it will be the IMAP append command. And I say might because it depends on how the append command was issued. If the command was issued with no timestamp argument, then typically the messages would get the timestamp of the date and time when that operation took place. If the append command was issued with a timestamp argument, then the server might take that argument and use that as the internal date for that message. So you should know that there could be different scenarios here. So if we look at the server metadata for this specific message that we examined, I just included a printout here on the left side for your reference. You see that the UIDs are, when you sort by internal date, so they are in chronological order within the folder, you see that the UIDs are not sequential. So it goes 75, 74, 05, 06. I would expect to have 07 here, but there's a UID that's way later. So this could point out to a situation where this message was taken out, like downloaded as an EML file, for instance, manipulated, and then synced back to the server. And that's something you could easily do with Thunderbird, for example. Just sync the folder, drag the EML back into the folder, delete the old one, send and receive or sync, and it goes in there after a cycle of IMAP commands. So when you look, you will see a discrepancy like this that points out that something is out of whack. So now I'm looking at a specific message that I'm interested in, and I'm examining this, but I'll show you very briefly how you would examine this generally. So let's go back to my other screen here. So let's say that we have collected an entire folder of messages from an IMAP server. So we have the service IDs, the folder where they came from, the MIME hashes, the output paths and the flags and everything. These two fields here are kind of critical, and they are the IMAP UIDs and the internal dates side by side. So we could, for example, when we sort by internal date, we could scan easily for IMAP UIDs that are out of sequence. This entire file I have is all for a single folder, and the UIDs are unique within the folder, so I could do this type of analysis at the folder level. So I'm going to do a quick Excel check here. I'll say, find me all instances where this is larger than its neighbor. Let's see what I find. I find one. So let me mark this row 492, and go back here and go to 492 again. Yeah, so if you look at the row that I marked, this is a different message, but again, the same situation here. So I have a folder full of UIDs, and the UIDs are going sequentially and nicely, but I have one UID that's in date order, but when you look at its UID itself, it jumped way out, almost going all the way to the end of the folder. It would have belonged somewhere around here. So that's a red flag right there, and it doesn't necessarily prove to you that the message is fraudulent, but at least it tells you that something might have happened to that message. It's not an ordinary SMTP received message at the time that it appears. There's something there to explain. So that's part of IMAP metadata. Now, metadata, server metadata, is not just limited to IMAP servers. There's server metadata in Exchange servers. There's a whole host of it. There are logs, audit logs in G Suite and Office 365. But also there's Gmail server metadata. Again, Gmail has internal dates that you can get with API. And also Gmail has another interesting data point that's called history records. So I'll talk about that briefly. There's also thread IDs and label IDs here. So the thread IDs are essentially the threading information that you would use to thread Gmail conversations together. It could give you some clues about messages. For example, if a message is taken and changed and it appears to be unrelated to a set of messages, but the thread ID ties them together, then that could be a clue. And the history records are kind of interesting. So let me talk about that very briefly. Let me switch over again. Sorry to be jumping back and forth here so much. So I'll show you a brief history record export here. So let's first do a history record introduction. So Gmail API has a concept of history records. And the purpose of these records is to make it efficient for email clients, not forensic email clients, but general email clients, to sync the email messages from the server. So when the email client first connects to a mailbox, it does a full sync. So it requests a full listing of everything that's on the server, and it stores that somehow and it presents it to the user. Now let's say that the user closed out of the email client and came back the next day, and they connected again and they want to get their new emails. So one way to do that would be to request another full list from the server and then compare. Another way to do that might be to request a new list starting from the last date of the most recent message that you already have. But then that's a little bit tricky. What if some time changes happened or things got moved around or migrated? So the more accurate method that Gmail came up with is to publish history of records. So what the email client does is it requests the full sync, and then it keeps track of the last history ID that it fetched. And then the next time it does a partial sync by passing the history ID of the most recent message and requesting a history of all the events in the mailbox from that point forward. So it gives you a list of history events that took place after that point. And what are those events? Where there are generally 4 groups of events. There are labels added, labels removed, messages added, and messages deleted from the server. So this is great and not so great. It has some caveats, basically. One of the great aspects of this is that it gives you an audit trail of some sort that you don't have available to you any other way, especially for free Gmail accounts. The limitation is that these records don't live very long. In my testing, I see them going up to about a month or so. They could be even shorter lived sometimes. And the other thing is the records themselves don't have timestamps individually, but there are certain records that indicate messages being added to the mailbox, and those messages have timestamps, so you could use those as anchor records to determine what happened. And what happened, it could be that somebody marked a previously read message as unread, or it could be that somebody deleted a message when they shouldn't have because there was a litigation hold in place, or a bunch of other, they moved the message to trash, a bunch of other events that happen. So the records are fetched like this, and you'll see that there are different events here. For example, let me look for one. Here's a record where there are messages added, for example, and I'm seeing the message added and it's metadata. That could be some, for example, here's a record where a label was added, and the label that was added to the message is the unread label, and the message is this. So this tells me that somebody took this message with this subject and they applied the unread label to it. So in effect, they marked it as unread when it had previously been read. So things like that. So this is just a good supplement, and it's a good example of server metadata that you don't get immediately by doing a traditional acquisition, where you need to go out there and fetch it from the server and supplement. So let's summarize here, because we have we're running out of time too. We already have. So in summary, it's important to understand that we need to preserve the messages in their original format, as close to the original as possible, because there's a bunch of investigative techniques like DKIM signature checks, content length checks, and other metadata and data points in the message, and they will be thrown off by conversions. So if you take a message, and I've seen this happen a number of times, forensic examiner acquires messages from Yahoo, let's say, but instead of acquiring them in the original format they're in, they acquire them into an Outlook PST, and then they export from there, and everything goes haywire because of that conversion. So you don't want to do that. You want to keep them in their original format. The second thing is, most of the time, you don't want to capture just the message that you're interested in. You want to capture it with its neighbors. So ideally, I like to do a full mailbox acquisition, but if I'm not allowed to do that at a minimum, I would like to do a folder acquisition, or at least the messages I'm interested in and its immediate neighbors, maybe 20 neighbors on each side, so that I can see them in context. If I see just the message itself, and if there's not enough conclusive evidence that it's authentic, then just because it sits on an email server doesn't mean that it's not altered. So to prove that, you have to show that the server metadata also checks out, and you have to capture it and examine it in context. So let me stop here for a second. And I saw a few things bubble up here. Let me pause and answer some question here. So let's take a look at some of the questions. So first, take a look at the Q&A here. Somebody says, will you provide slides? Yeah, I can provide slides. The slides here are just a few. Honestly, there's not much in the slides, but I can definitely do that, no problem. Let's see in the chat. Do I see any questions here? For Gmail, does the MIME boundary timestamp hold the same purpose of the in reply to timestamp? Well, the exact purpose of these timestamps is kind of a mystery, because a MIME boundary doesn't really require a timestamp to be present in it. A simple MIME boundary could just be 2 hyphens, another hyphen, and another hyphen at the end, for example, like something very simple like that, or just a couple of simple characters in the middle. But the goal here is to make them unique, and in achieving that goal, a lot of software use timestamps. So that's the reason that I can imagine. And in reply to field, the same applies, because in that case you're looking at message IDs, and message IDs also have the same incentive to be unique. And in doing so, this time the email server tries to create unique message IDs, and you find some timestamps there sometimes. Let's see. There's a question about if there's a good resource that can be referenced to help ID timestamps within an email file. Well, we have a couple of blog posts on this on Metaspike's website. They start by dates in hiding, both of them. So there we kind of lay out the different timestamps that hide, especially in emails. And in the future, there might be some tools coming from us to handle this too. Let's see what else. Somebody's asking, is there a way to find out if the X originating IP is an actual user IP or a hidden IP use of any VPN is involved? Yes, sometimes. So the X originating IP used to be a header that sometimes told you the IP address of the original sender, but for privacy reasons, a lot of email providers have discontinued that, so you're not going to see that in Gmail, for example. That's going to show you the IP. If there's anything, it'll show you the IP of the server. But there might still be some email clients that reveal that information. And if you find that IP address, then you can use some APIs that are out there. And some of those APIs, for example, I think Security Trails has something like that, or MaxMind perhaps. They have an API that allows you to query, and you can see if an IP is going through a VPN or Tor or something like that, or if it's an end user IP. So yes, you can have some type of intelligence like that. it's probably not going to be 100% accurate, but it could be a good starting point. Let's see, another question. Does the UID change if you modify the message directly in Outlook rather than modifying it and then adding it back in? Well, that's a good question. But, well, so if you made, let's say that you have a message in Outlook and Outlook is connected to Gmail, right? If you go open your Outlook while it's disconnected, and if you edit that message, change a bunch of things, save it, then there's no UID to speak of because you're talking local. So you're in the local message and Outlook just changed the local copy of that message. But if you connect to the internet and if you allow Outlook to sync, then what it's going to do is it's going to go through a cycle of IMAP commands and it's going to find the older message that used to be there. It's going to delete it. It's going to expunge it. And then it's going to upload the new version of that message. And that's going to cause the UID to change because you're not going to be editing the old message. There's no such functionality. You'll be creating a new message and replacing the old one with it. So that's a new UID. Let's see, do you have a quick guide on an attorney might reference when asking for email in the discovery phase? I don't know if I do, but let me get back to you on that, Richard. We have a bunch of write-ups on Metaspike, and also at Meriden I have some discovery geared resources, so let me scan that to see if I might have a guide like that. If not, then maybe I can point to somewhere. I think I've covered all the questions I've seen here, and I don't want to take more time, so let me wrap up. And for anyone who's participated, thank you so much for making the time. And if any other questions come up later, feel free to get in touch. Here's my email. You can send me a note there, or you can hit me up on LinkedIn to chat some more. And if there's interest, I would like to do some more of these to cover some different scenarios, like I said, different type of email examinations, different examples, and perhaps one day we could even have some type of challenge where we can offer some suspect files and have you guys take a stab at it. All right, thanks again and enjoy your day.